Good morning, everyone, and welcome to the lecture. This is lecture number 8 in work, power, energy, and we are dealing with law of conservation of mechanical energy. In the previous class, we saw how we can do problems with law of conservation of mechanical energy. We saw the law of conservation of mechanical energy where it is applicable. It is only applicable where your conservative forces are present and non-conservative forces are not present, or if they are present, work done by them is zero. Work energy theorem, which can be applied everywhere, is known as the mother theorem. Lockme, which can be only applied when conservative forces are present, is known as the daughter theorem. Then we had seen the spring force and the energy stored in the spring. When the spring is in its relaxed state, there is no force and there is no energy. When the spring is extended or it is compressed, the spring will start to apply a force. If it is extended, it will try to pull back. If it is compressed, it will try to push. So spring can pull as well as push. In both cases, though, the energy stored in the spring is always taken as half kx square. It is not taken as minus half kx square because of the reason I have already discussed. Okay, then let us start the day with a problem. And what sort of problem are we going to encounter here? The sort of problem that we are going to encounter here are going to be pretty simple. They are going to be based on the concept of this spring. So here we have a spring of spring constant K, and you have a block of mass M moving with a velocity V on a smooth surface. Now, what is going to happen? This is a horizontal smooth surface. The block is going to get the block is going to come in contact with the spring, and it is going to compress the spring. What you have to find out is find the maximum compression in the spring. That is what we are going to find out here. When the block compresses the spring, what is the maximum compression in the spring? I'll give you 2 minutes to think about the problem, and if you can solve it, nothing like it, I'll give you 2 minutes. Your time starts now. Please try it. So how are you going to do it? You have to find the maximum compression in the spring. When will the spring be under maximum compression? When will be the spring under maximum compression? At some point. At some point, when the compression in the spring will be x naught or x, this block will come. It will come in contact with the spring. It has a velocity. It will keep on compressing the spring. It will keep on compressing the spring. As more and more spring gets compressed, the force in the spring becomes more and more. The velocity of body will keep on decreasing. Spring will keep on compressing. Up till this point B, let us say. What will happen at the point B? What is the special condition that will come at point B when the spring is in its maximum compressed state? What will be the velocity of the body of this mass when the spring is in maximum compressed state? Yes? Can you say
No,
anything?
sir.
Can you say anything about the velocity of the body when the spring is in its maximum compressed state? Yes?
Zero, sir.
Velocity at this point where the spring is in maximum compressed state will become zero. And at this point, let us say the velocity is, this point is A. What are the forces acting on this body? Can anyone tell me what are the forces that are going to act on this body when it is going to move from A to this point B? What are the forces acting on this body? No one knows what are the forces acting on this body?
Gravitational force,
Gravitational force,
normal force,
normal force, that's it,
Force.
and spring force. These are the three forces working on the body. What is the work done by normal reaction here? What is the work done by normal reaction here?
Zero, sir.
What is the work done by gravity here?
Zero, sir.
The only thing that is doing any work is spring force. Yes or no? And that is a conservative force. So I can apply Lockme, law of conservation of mechanical energy. I can apply it from the initial point A to the final point B. What does Lockme state? Mechanical energy at point A is equal to mechanical energy at point B. Mechanical energy at point A consists of kinetic energy at point A plus potential energy at point A. Mechanical energy at point B consists of kinetic energy at point B plus the potential energy at point B. Now I may ask, what is the kinetic energy at point A?
Half mv square.
Half mv square plus. Now, it has two types of potential energy. One is gravitational potential energy and one is spring potential energy. At point A, does it have any type of potential energy?
Zero, sir.
Because for gravitational potential energy, this is the lowest point. It has zero energy, no gravitational potential energy and no spring potential energy. When I come at point B, what is the kinetic energy at point B?
Zero, sir.
Zero, sir. Good. What is the potential energy at point B?
mgh.
Half a square. 1/2 kx square.
Half kx square. That is the potential energy which is stored in the spring. That's it. We solve this and we get your answer. Half and half go away and you will get the value of x equal to v into under root of m by k. That is the maximum compression in the spring. Do we understand this? Anyone got the answer for this? Okay, no problem. I'll give you 2 minutes to note this question down till I get to the next one. Have you noted it down, everyone?
Completed, sir.
This is the next question. Question number 2. You have a block of mass m at rest on the top of a hill. The height of the hill from the ground is h. There is no friction anywhere. What I'm going to do is I'm going to drop this from this point. It is going to fall down, and as expected, there is a spring on the other end. It is going to go and compress the spring. The question still remains, find the maximum compression in the spring. Can you do this question? I'll give you 2 minutes. Everyone, please try. So how are you going to do this? Well, simple. Let me call this point as A, and let me call this point as B, where the spring is in its maximum compressed state. We know that when the spring is in its maximum compressed state, the block has to stop. The velocity of the block has to be 0 at this point. What are the forces that are going to work on this block as you go from point A to point B? What are the forces here? What are the forces that are going to work here?
Gravitational force,
Gravitational,
normal force,
normal force,
spring force.
and spring force. Gravitational force is going to work everywhere. Normal reaction is going to work everywhere. But spring force is only going to work over a short distance. What is the work done by normal reaction?
0.
So normal reaction is 0. The other two forces are gravitational force, conservative force, spring force, conservative force. So that gives me a license to apply law of conservation of mechanical energy, and I'll apply it from the point A, the highest point, to the point B. Mechanical energy at point A is equal to mechanical energy at point B. At point A, we have kinetic energy plus potential energy. At point B, we have kinetic energy plus potential energy. What is the kinetic energy at point A?
0, sir.
It is at rest,
0.
so 0. Now, as soon as you talk about potential energy, there are two types of potential energy is going to come. So for gravitational potential energy, I can take the lowest point as 0, 0 energy. Having said that, now can you tell me what is the potential energy it has at point A?
MGH.
It has gravitational potential energy plus mgh. There is no spring, so there is no spring potential energy. So that is it. That must be equal to What is the kinetic energy at point B?
Half kx square.
Kinetic energy at point B?
0.
0. Plus, what is the potential energy at point B? Now, the gravitational potential energy is 0 because we have taken it at the ground point. But instead of gravitational potential energy, it now has spring energy. How much is the spring potential energy?
Half kx square.
Half kx square. That's it. From there, you should be able to calculate the value of x, and the value of x that I think you will get would be under root of 2 mgx mgh by k, and that is the answer that we were looking at. Everyone got this?
Sir.
Okay. Everyone has noted this down? Then we can move on to the next question. What is the next question? Similar scenario, but now the spring is like this. And the block is here. And this height is given as h. And obviously at this point it is at rest. It is going to fall on this spring, different way though, and it is going to compress the spring. Again, the question remains same. Find the maximum compression in the spring, and I'll give you 2 minutes to do that. So how are you supposed to do this question? The first question is, what are the forces acting on this body? If I call this point as A, and then it will have maximum compression, let us say X, at the point B. What are the forces acting on this body from A to B?
Gravitational force, normal force, and spring force.
From where did the normal force come?
There is no normal.
There is no normal force unless and until you call the spring force as normal force. Okay, there is no normal force here. There is only gravitational force and spring force, and both of these forces are conservative in nature. So now you can apply log में from point A to B. Total mechanical energy at point A should be equal to total mechanical energy at point B. I keep on saying this every time so that you remember it. Talking about mechanical energy, kinetic energy at point A plus potential energy at point A should be equal to kinetic energy at point B plus potential energy at point B. Now, what is the kinetic energy at point A?
0.
The block is at rest, so 0. Now, as soon as I talk about the potential energy at point A, now what type of potential energy it has at point A? What type of potential? It has gravitational potential energy, yes or no? So, for gravitational potential energy, we have to take a reference point whose energy can be taken as 0. Now, which point are we going to take? I always take the lowest point, and I think this is the lowest point. So, I take the gravitational potential energy of this point as 0. Do we understand this? I always take the lowest point. Sorry. And the lowest point here is the point B. Okay, so gravitational potential energy of point B is taken as 0. Now, what is the gravitational potential energy of point A?
mgh.
Open your eyes. Take a deep breath. See what do you see and then tell me. What is the gravitational potential energy at point A? Diagram is the most important thing in this question. And I hope that you have this habit of drawing diagrams. If you don't draw a diagram,
MB into H plus X.
yes, mg into h plus x. Because the height of the point A with respect to point B is h plus x now. That must be equal to kinetic energy at point B. How much is the kinetic energy at point B?
0.
What is the potential energy at point B now? At point B, the gravitational potential energy is 0, but it has some other type of potential energy. Which one? What is the potential energy at point B, my dear friends?
Half kx square.
It has spring potential energy. Now the problem is, it does not remain a simple equation and it becomes a problem of math. How are you going to solve it? Because now this becomes a quadratic equation. So I will write it in the form of quadratic equation. In terms of quadratic equation, it would be kx square minus 2 mgx minus 2 mgh is equal to 0. This is how the equation would look like once I take this 2 and multiply it here, and then I take the terms on the other side. Now, I hope you know how to solve this quadratic equation, yes or no? Once you solve this quadratic equation, you will get two values. One value will not be possible. The other value is the value that we are going to take. So what will be the value of x that we are going to get? Oops, wrong color. What is the value of x that you are going to get from this quadratic equation? Remember how to solve this quadratic equation? Anyone can tell me the answer for this? Do you know quadratic equation? Yes or no? Can you tell me the answer for this one then? No one?
2 mg plus or minus under root 4 m square g square plus 4 k mg h by 2 k sir.
2 mg plus or minus under root of 4 m square g square plus 8, I think 8 m g h into k divided by 2k. Yes or no? That is the result that we are going to get. So which value should I take? Should I take the positive one or should I take the negative one? Because there are two values. Should I take the positive one or should I take the negative one? Which value of x should I take? The positive one or the negative one? Well, I will take the positive one because the negative value of x, the negative value of the root, if I take that negative value, the value of root will be more than 2 mg, and that will give me the value of x as negative. As you can see, x is not negative, x has to be positive. So I have to take the positive value. So my dear friends, the answer becomes 2 mg plus under root of 8 m square g square plus 8 mghk divided by 2k, and that is your final answer. The answer looks a bit difficult. The only reason why it looks difficult is because of this factor coming here, h plus x. Because of this factor coming here, h plus x, that the problem looks a bit complicated. We understand this, everyone? Yes or no?
Sir.
Okay. Well done. Then let me ask you this one. Again, remember that we are expecting question from springs and spring energies and this one. So can you solve this one? Question number 4 or 5 or whatever it is. A long spring is stretched by 2 centimeters. Its potential energy is U. If the spring is stretched by 10 centimeters, what will be the potential energy stored? And your answer is in terms of U. I'll give you 2 minutes to do this. So, how do you get the answer? It is pretty simple. You just have to remember the potential energy in the spring is proportional to half kx square. So, you can see that the spring potential energy is proportional to x square. So, U2 by U1, final energy by initial energy, will be x2 by x1 squared. U2 by U1, x2 is 10, x1 is 2 squared, and you get your final answer, and the final answer would be 25 times U. Do we understand this? Yes or no? Okay. Anyone has noted this down? Anyone has understood this? Now comes this question. Two springs of spring constant. The spring constants are different, as you can see, are stretched with the same force. Okay. What will be the ratio of their potential energies? I'll give you 2 minutes to give me the answer for this one. Now remember, this is the reason this question was given. Energy is half kx square. The potential energy stored in the spring is half kx square. But this is not the only formula that you can use here. You can write this formula in a different way. Remember, F is equal to kx. F is equal to kx. So I can write this as half F multiplied by x Or I can also write it as, can write x as F by K, or I can write it as F square by 2K. These are the three different ways in which I can write this potential energy. Do we understand this? Now comparing this yellow one and this yellow one. Remember, they are stretched by the same force. So I can say U2 by U1, or for that matter, U1 by U2. Let me write U1 by U2. Energy in the first spring divided by energy in the second spring. As you can see, this U is inversely proportional to K. So that will be equal to K2 by K1. Do we understand this? Yes or no? So it is not directly proportional to K because here the force is same. So this is not directly proportional to K. Energy is inversely proportional to K, and therefore the answer is not 1:2, but the answer is 2:1. Do we understand this? If the same question would have been asked in such a way that x is same, their extensions are same, then you would have come directly proportional to K. You understand this? But the question was asked in a different way. Force stretching that spring is same, and therefore the answer becomes inversely proportional to K. So these are the small things that you should remember. Do we understand this? Okay, please note it down. Have you noted down? Then comes this question. A spring initially stretched by an amount x1 is further stretched to a value x2. So in the initial case, the extension in the spring was x1, and now the extension is made x2. And obviously to extend it further, I have applied an external force. Now in this process, find the work done by the spring and work done by the external force. Now whenever this question comes or this type of question comes, it may be mentioned, it may not be mentioned, but one thing is important, the process is done very slowly. Now what this statement means, the process is done very slowly. This statement means that the change in kinetic energy is zero. So we do it very, very slowly so that the kinetic energy does not change. We do it very, 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 very slowly. So that is the main aspect of this question, that the change in kinetic energy is zero. We are asked to find out the work done by the spring, and we are also asked to find out the work done by the external force. This question is given for a very specific reason, We are supposed to understand something from this question, and I'll give you 2 minutes to try it. Anyone with any answer? Well, I will give this question as a food for thought, as a homework, so that you can try this question, and then we will discuss it in the next class, and we will see how, if a question comes and sometimes they ask you the work done by the external force, how do you find out the work done by the external force? So we will discuss it in the next class, and we will also try to see some more things in the next class. Tell me, was your integration completed? Integration completed, everyone? Great. Then we will do the other problems which we have skipped. So we will do that in the tomorrow's class, and we'll try to wind that thing up. So I'll see you in the next class. Take care. God bless you all. Bye bye.
Thank you, sir.
Try this problem at home.